Hello, this is Dr. Fitzgerald, and in this session we want to discuss simplifying radicals with variables. Our examples that we'll look at breaking down the cube root. So let's look at this example. Let's start with the cube root of x cubed. We'll have the cube root of x cubed. That's simply going to give me x. Let's go one further. Let's look at the cubed root of x to the fourth. And the question I like to ask is 4 divisible by 3? Is 4 divisible by 3? And the answer is no, it's not completely divisible by 3. So what I want to do is drop down an index. And if I drop down, not an index, a variable, exponent. And when I drop down 1, I want to ask myself, is 3 divisible by 3? And the answer is yes. So I want to rewrite x to the fourth as x cubed times x. Notice that's still x to the fourth. Now we can break this guy up, and remember we're looking at the cube root. Now, recall the rule where we can take the cube root of x cubed and the cube root of x. We have our perfect cube part, so this is the perfect cube, and then this part is the leftover part. This is my leftover part. So the x is the leftover part. And this is my perfect cube. The first part is the perfect cube part. So when we break this guy down, this will simply equal x times the cube root of x, and that would be the final answer for that particular problem. Let's look at one other. Let's look at if I have the cube root of x to the fifth. Now recall the question that we asked ourselves. Is our exponent divisible by the index? So is 5 divisible by 3? Is 5 divisible by 3? The answer is no. So I'm going to drop the exponent down 1, and the next number is 4. Is 4 divisible by 3? The answer is still no, so I have to go down 1 further. So I want to rewrite x to the fifth as x cubed times x squared, because 3 is divisible by 3. So in this particular case, now we want to go ahead and simplify this guy. And when I simplify this, we simplify it. Remember, the x cubed, that's my perfect cube part, and that the x squared is the leftover part. So when I simplify this, we have x times the cube root of x squared. And that would be the final answer for this. And one last example. We'll look at if I had the cube root of x to the 6, the cube root of x to the 6. So in this particular case, what I want to do is ask myself, is my exponent, which is 6, is that divisible by our index, which is 3? So the answer is yes. So I don't have to rewrite this. This guy is a perfect cube, and 6 divided by 3 is 2. My answer for this problem is x squared. And why is that if you think about it? X squared times x squared times x squared gives me x to the 6. That's why x squared is a perfect cube. So that's breaking down the cube root in a faster fashion. Some of you guys may not like rewriting it in this manner. So let's look at it in my other context. So over on the other side, we're going to do the exact same problems, but breaking it down using what I call the circle method. So in this particular case, I want to look at breaking down the cube root of x cubed. Well, how am I going to do that? Instead of rewriting, what we would do is rewrite this as x times x times x. That's my x cubed. And because my index in this particular case is 3, because my index is 3, I want to circle 3's. And so my final answer is going to be x raised to the number of circles that I have. And in this particular example, the number of circles is 1, so x to the first power. So my answer is just x. And notice we've saw that over on that example. So let's look at one other. We're going to continue these examples. So what if I had over here the cube root of x to the fourth. All right, so in this particular case, I want a cube root, and x to the fourth. That's just 4 x's. X times x times x times x. However, once again, we said we want to circle 3's. So in this particular case, I circle that, and I have an odd man left out. So once again, my final answer is going to be x raised to the number of circles that I have. How many groups of 3, or how many circles do I have? That's to the first power. And what's left over? The leftover part still is the cube root of x. So the cube root of x. So let's look at, notice this guy is exactly what we got on this other side. So let's look at the cube root of x to the fifth. Cube root of x to the fifth. In this particular case, once again, my cube root, in this case, we need 5. X is 1, 2, 3, 4, 5. And once again, I want to circle 3's. And why am I circling 3's? Because once again, my index is a 3. So in this particular case, my final answer is going to be x to the first power, because there's only one circle there. X to the first power. And then what's left over? Cube root of x squared. Why is that? Because there are 2 of them left over. And lastly, our last example that we see on the board here is the cube root of x to the 6th. So in this particular case, I want to draw out 6 x's. 1, 2, 3, 4, 5, 6. Then I want to go in again and I want to circle my 3's. So I have 1 group of 3 and I have 2 groups of 3. So in this case, our final answer is going to be x to the, how many circles of 3's do we have? 2. So x squared. So these are 2 different methods of breaking down radicals with variables. Now notice, this is the only works when we're working with our radicals in this particular case, looking at if 6 was divisible by 3, etc. However, these are 2 different methods that we would use in breaking down our radicals, and we have some examples that we want to be able to try. I want you to try at home. I want you to try to see if you can break down for me. What if I had the cube root of x to the, say, 8th power? And then also try if you have the cube root of x to the 9th power. So see if you guys can do those examples for me and have those ready to turn in. Thank you.